Well, welcome everybody to HydroTerra's latest webinar. Today, the topic is how much cleanup is enough in a world where contamination levels continue to rise, a reflection on the practicability of groundwater cleanup. Our presenter is Ross Edwards, who's Senior Principal from JBS&G. And thanks very much, Ross, for presenting today.
No problem.
Before we get started, I would like to begin by acknowledging that we conduct our work across this great land, and for that privilege, we would like to thank the traditional owners. HydroTerra respectfully acknowledges the Boonwurrung people of the Kulin Nation where we are located today, and we pay our respects to their elders, past and present. There's a picture of Ross. A little bit about our presenter. Ross is a senior principal at JBS&G with over 25 years of experience tackling contaminated land issues across Australia and overseas. Based in Victoria, he has worked all over the country on everything from the Defence PFAS program, major industrial cleanup and redevelopment to major infrastructure projects, guiding teams through complex investigations, risk assessments and cleanup strategies. Ross balances technical depth with practical real-world solutions, particularly when it comes to emerging contaminants like PFAS. He's led some challenging remediation projects and has a deep understanding of how to turn data into action. I also got a little bit more background from Ross of how he got into this game. He first studied geology at school, which was back in the UK, and then he went on and studied environmental geology at a UK university in Portsmouth. He came to Australia and started working at Golders, and since then has worked at several consultancies, and obviously now is working at JBS&G. I would say Ross is a passionate person about undertaking remediation, and it's great to have his experience here today. As you all know, we love your questions. Please use the Q&A button at the top of your screen to raise those questions, and Ross and myself will do our best to answer those questions once the presentation has finished. Thanks also to all of you who provided us with early bird questions. Why does HydroTerra do these webinars? We like to share knowledge, like to facilitate education, and we like to take an industry leadership position. Without further ado, I will hand over to Ross.
Thanks, Richard, and thanks everybody for coming along. I might jump into the next slide, but we've talked about title, but yeah, really today it's as the title suggests, it's a combination, I think, in terms of what I will talk about. So, talk about groundwater cleanup, really in the context of Victoria, but it's guidance that we use here, but it's not something that's can be applicable across every other state in Australia in terms of the information that guidance is looking for. So it's really to talk through that, but it's also talking about the impacts of how that criteria shift and regulatory shift over time is looking at a groundwater cleanup and the practicality of cleanup, and in the context of that guidance, how that regulatory shift and change over time influences your approach to remediation of different contaminants. I got a kind of longish history in the history of PFAS and per and polyfluoroalkyl substances, or PFAS for short. I've been involved in a number of sites over the last 10 years. So in terms of an emerging contaminants, it's an example I'll kind of use in the conversation on the slides as to how that's kind of impacting on our approach to remediation. because PFAS itself is quite a persistent, mobile and toxic contaminant. It's driven some very kind of key shifts, though, certainly over the last 5 to 10 years, which was resulted in very diffuse, dispersed and long plumes in groundwater, particularly. Just in terms of this slide and the picture here, it's obvious Australia's obviously not immune to. It's not the only one that's grappling with the likes of PFAS, and this is a study that looks at the global surface water and groundwater sites that are being affected by PFAS, with Australia down in the right-hand corner. You can see a number of sites around the country, often driven by PFAS investigation remediation programs, and they're what they are in Australia. But you can see across Europe and America, there's obviously some. When you're looking at the top slide, the darker circles are kind of representative of deeper concentrate or higher concentrations of PFAS in surface water and groundwater, and that is probably from a first observation. The US and Europe have been more associated with the actual manufacture of PFAS compounds themselves to be used in products, whereas Australia has never really manufactured PFAS. It's only used products such as aqueous film forming foam that has those compounds in. So as a first observation, I guess, of a global scale, there are obviously impacts in Australia, but the depths of the impacts in some of those source sites are much higher in say, the US, where PFAS was actually manufactured. Next slide, please.
Before we do, so groundwater cleanup expectations are shifting amidst rising detection. So we know there's more of it. Are we also becoming more aware that it's more toxic? Is that what we're saying? And therefore, not only do we know there's more of it, we're expecting to clean it up to higher levels. Is that what you're saying?
Yeah, or lower levels, in fact. Yeah. So I suppose the best thing to look at is, the toxicology is evolving. It's in contaminated land terms. You've got contaminant that only really was detected in the late 90s initially, and that the ability for laboratories to detect it has improved over the last couple of decades. But it is through that and through the advances of the science, and particularly the understanding of toxicology, there are these shifts that you see, and I'll talk about in later slides, in terms of, certainly in the Australian context, these kind of relatively rapid, in contaminant terms, shifts in criteria over time.
Thank you.
So just a bit about the specific EPA guidance for the cleanup and management of contaminated water. Again, it's in a logical sense, it sets a process for cleanup of groundwater. So really the EPA's expectation is, with a contaminated site, and it's certainly an expectation in this guidance, you don't just clean up as far as practicable straight off the bat. The expectation is the preference is to eliminate the risk of harm. So a full cleanup of groundwater. When you've looked at that and looked at the technology and a range of factors, you then start working down the path and looking through the key principles of cleanup. So beyond risk elimination, you're then looking at risk reduction. And up in the right-hand corner there, you can see kind of the risk hierarchy, I suppose, in terms of risk reduction. So through cleanup to the extent practicable, you are looking at a risk reduction process, which I'll talk about in terms of the detail, but it's not just an easy process. I guess you have to have a high level of information to justify your endpoint for cleanup based on risk and understanding of the contamination and future mobility. So there's a strong evidence base to that, and the guidance kind of talks to that in terms of the level of detail that's required. And then once cleanup is achieved, to the extent practical, you're recognising there is a residual contaminant impact in groundwater and on sites, and it is that dynamic process is built in, and I'll talk about how that's kind of monitored, your monitoring of residual risk effectively when you've reached cleanup to the extent practicable or CUSFARP at the end of the process. So the guidance is enshrined in environmental auditor documents or one of the documents that environmental auditors have to consider in the conduct of environmental audits, and it's a guidance document that EPA leans on quite heavily, and certainly it's links through to the Environment Act and your duties under the Environment Act to manage sites that have contamination. So it really does one of the key documents that forms the technical and legal base for transitioning those contaminated sites through to a safe use.
Are we sort of, well, from your experience, are we now really in a place where the criteria are coming down so much that really we've given up on being that top row, eliminate, and we are predominantly operating in just reduce risk?
I think there's always that first pass is that expectation, I think, at the end of the day. So inevitably we'll kind of touch on things in later slides. You do face a practicality element when, especially with PFAS and kind of the longer contaminants that produce kind of a more low and diffuse plume that may extend beyond the site and off-site. Then practicality of cleanup to reach cleanup objectives, environmental values, as EPA Victoria calls them. In Victoria, it becomes harder because of just the size of those contaminant plumes in groundwater. So yeah, the risk elimination is the desirable starting point, and in some cases you're able to achieve that. It depends on your type of contaminants and your mix of contaminants at the end of the day. Yeah, so just a bit more in terms of the key steps. There is a lot of detail in the guidance, but these are key steps. So stepping through, first element is to really look at, is your groundwater contaminated? So it's confirming, firstly, the presence of contamination, and under the Act, groundwater is defined as concentrations above background levels. And then whether it creates a risk of harm to human health and the environment. So the first test of that, when we're looking at an investigation and looking at contamination, we may have identified as part of that investigation, screening it against Tier 1 screening criteria. So they're quite conservative, and as I step through this, you start looking more at the site-specific level with the steps beyond those Tier 1 criteria. In that initial assessment of risk, you're looking at whether that risk is unacceptable. So a good understanding of activities on your site and the site conceptual model to understand the true linkage between contaminant sources, those pathways to kind of human and environmental receptors. And then once you've got a firm understanding of that, both on and off site, is looking at whether the risk, as I've noted on previous slides, can it first be eliminated as a preference, and then, so far as reasonably practicable, where not, or CUSFARP. That's where you start working through the steps and providing information to demonstrate you're looking at the technologies and cleanup endpoints that are risk-based to achieve cleanup and look at practicality of cleanup. Once you've gone through that and identified your cleanup technologies and the cleanup approach, it's then implementing and validating it. And again, you will reach when you're looking at practicability, a level of residual contamination that then requires you to monitor and review contamination on site. So it may, for example, it may be at the end of cleanup, once you've demonstrated cleanup and reducing contaminant concentrations, but a residual, having a groundwater quality management plan in place to monitor the risk and have triggers and contingent actions in the case that you may, if you saw groundwater concentrations go up again, there'd be contingent actions to take to manage the risk. Next slide, please.
Just from your experience, what sort of percentage of sites end up going down to that last step of ongoing monitoring?
I would say, I've got to do a mental calculation.
Roughly.
Oh yeah, so I wouldn't going to be super. It's probably about 95% in my, but you know, maybe I'm just looking at very dirty sites that are complicated. Yeah.
They all have ongoing monitoring.
Yeah.
Good. Better give auditor a call. No, that does sound good.
So these next few slides are just kind of looking at influences on that when you're looking at practicability, looking at the influences on that process. So a key one is, again, I'm going to lean on PFAS, which is one that really does influence this thinking, but difference between ambient and background concentrations. There's, especially in Victoria, there's probably a nuance with national guidance such as the NEPM, the National Environmental Protection Measure for Contaminated Land Assessment. The EPA Victoria talks about background, and those are they're really more the natural concentrations, so natural mineralisation, say in basalt aquifers. You might be picking up natural metal levels such as nickel and copper. Ambient concentrations are really those impacts from anthropogenic sources. So again, PFAS is an easy one to use as an example, and these are the examples on the slide, where you have obviously source sites that are contributing to that and resulting in anthropogenic influence on surface water and groundwater. And these slides show you some of the this is an academic monitoring, but also the table 2 there you can see on the screen is from the PFAS National Environmental Management Plan, PFAS NEMP, which is looking at monitoring that was done by EPA Victoria. You can see there in the urban catchments, there is certainly a level of background in sampling in surface water and groundwater. So that's something you have to think about in terms of your background. You're always, when you're looking at a source site, you're always looking at the influence of off-site sources, and whether your site is actually the source or whether it is a background contribution. But it is those are very particular kind of elements to consideration of background, where you have naturally occurring background and then ambient. And it's not ambient concentrations aren't an excuse, as part of the CUSFARP process for not cleaning up a site to a great extent. So you do have to still acknowledge background concentrations, but it's not, you can't just kind of fall back on those in terms of ultimately cleaning up your site to an extent.
Have they detected PFAS in rainfall?
I've seen some papers that have, yes. So that first slide that we had does talk to a global problem. It is a bit like microplastics to some extent. You've kind of got this contribution. I think I've even seen a paper with microplastics where the sea is almost becoming a source of microplastics. So you're kind of getting onto a broader scale problem in some senses.
So groundwater recharge, clean it up to a pristine level and then recharge it back up with PFAS is potentially on the cards, or the concentrations are so small in rainfall that it's...
Yeah, I think I for a while since I've read the paper, but it's acknowledging that is a potential, but I think, its contribution when you're looking at cleanup is not something you can ultimately fall back on. It's in rainfall and clean up. You're looking at, I guess, a minor background contribution at the moment, certainly in the more remote regions of Victoria.
Yeah. Shall I move to the next slide?
Yes, please. And again, this is another element that when we're looking at cleanup is that change in criteria over time. There's two tables just on the right-hand side. This top one is looking at kind of a range of contaminants other than PFAS, and then the bottom one is obviously looking at different PFAS compounds that are essentially covered by guidance in Australia. So PFAS is one, again, because of its relatively recent discovery, and certainly since 2018, where Australian guidance has been published. We're looking at obviously having one is kind of a guidance to work at initially. In that top line, you're seeing a drinking water criteria for PFAS and PFHSS of 0.07 micrograms a litre. Those give us a target to, again, when you're screening risk to when you're looking at remediation of a site, that is an initial screen of that risk until you start looking at a site-specific level. And then from an ecosystem protection point of view, those criteria coming in also set quite a very low concentration. You can see there 0.00023 micrograms a litre in groundwater. So the labs, when you're looking at concentrations of that level, you end up, the labs initially struggle to reach that concentration in terms of detection limits, but also you get these low and diffuse plumes that just extend from PFAS sources on site. And compared to other contaminants, PFAS results in, because of those when you're looking at screening criteria, you can get some groundwater plumes that extend for kilometres. So that does extend your footprint and the capture of risk in the footprint of those contaminant plumes. So that obviously, when you're looking at cleanup and the extent of cleanup, that does start feeding into your considerations around practicability of cleanup when you've got a low and diffuse plume over a very wide area, compared to, say, hydrocarbon plumes and solvent plumes, which can still be hundreds of meters, but not necessarily kilometers, as some of the examples we've seen both nationally and internationally in contaminant plumes.
Maybe I'm out of date, but if you've got facilities in the area that haven't been triggered to do a cleanup because they haven't done anything to trigger a planning process, and they're contributing to PFAS that's going into the groundwater. It used to be, well, I still think it is, that you, as the person downstream, would pursue them for pollution that was coming onto your site, right? So the sort of polluter pays principle. So this sort of background concept of PFAS is effectively saying we don't know who those polluters are. There's that many sites that have got it, or you see the point I'm trying to make here?
Yeah, no, there's still acknowledgement. You're not really defaulting to an overall ambient outlook on life. You do acknowledge. I think PFAS source sites still have to kind of acknowledge that they are a source site, and it is, going back to your point, the background source sites are again considered as part of that overall cleanup, and where they are seen to contribute to the overall contaminant plume and PFAS in groundwater especially. That is part of the information and assessment that you do as part of practicality of cleanup. And then I suppose you then start getting into a conversation about whether you are the source site or there is contribution from other background sources. But it is part of that information package almost that then feeds into the CUSFARP process that is then more often than not feeds into the audit process, and the auditor looks at determining CUSFARP will clean up to the extent practicable, taking into account background source contribution from source sites.
When it's so diffuse. Shall I move to the next slide?
Yes, please. So another important element of the overall assessment of cleanup to the extent practicable is that, managing the risks to human health and the environment, both on and off site. So whatever the contaminants, it's really just being very specific about the exposure pathways specific to the site and the area that is affected by a particular groundwater plume. So again, it's really just reinforcing the importance of a good conceptual site model, so you can demonstrate and understand your connection between source, the contaminant, the pathways for that contamination in groundwater and the human and ecological receptors, so whether that's use of drinking water or otherwise. So that's all contaminants, but I suppose in a PFAS specific sense, and to talk to previous comments I made on other slides, you have changing criteria. You do have these kind of low and diffuse plumes, and that footprint with the mobility and persistence of PFAS, you do have those larger plumes that have a broader capture of potential groundwater users at the end of the day. So you do have a broader capture of potential receptors to that contamination. And with PFAS, the primary pathway for risk in risk terms is through ingestion or drinking. You're less of an issue in terms of vapor. People try to make PFAS volatile, but it is primary pathway is really that drinking or ingestion pathway, and less of a dermal pathway as well. So you do have to understand the kind of broader use. It just widens your conceptual site model, especially when these plumes are quite large. They don't stay confined to a site conveniently. You're having to assess risk on a broader scale and potentially a wider capture of groundwater users at the end of the day.
Are the wastewater treatment plants currently capable of treating PFAS that they're receiving?
I think they obviously take in, they do they're an essential service at the end of the day, because they're taking in a lot of waste from domestic and industrial sources. So obviously they're doing a lot of work in the background to address the contaminant profile that comes into those wastewater treatment plants. And that's where you get to, I suppose. As with remediation of groundwater, there is wastewater organisations that are looking at that are trying to obviously address the science as it evolves, just as we are with cleanup of groundwater for contaminated sites.
To ask it in a different way, if with the testing regime for, say, recycled water reuse, does that include a PFAS criteria at the moment?
I think there is a risk framework for recycled water, and there's EPA guidance that links to that. Specific criteria would point back to obviously recycled water is often not used for drinking water, obviously. So again, that risk framework is looking at the potential use of that recycled water. So by extension, you're almost kind of looking at the site's activity-specific risk associated with the use of recycled water.
Yeah. Okay. If anyone knows, log it in the chat. That'd be great just to know if we do have a criteria around that. Shall I move to the next slide?
Yes, please. Yeah, so obviously when we're looking at practicability of cleanup, there are many tools in the toolbox around the different contaminants that we have, but really when you're looking at more persistent contaminants that potentially go off site, early in contaminated land, it kind of evolved from pump and treat, and then really the first wave of contaminants, this is during the 80s and 90s almost, is kind of more the volatile contaminants and the VOCs, so compounds like TCE and benzene. Initially kind of pump and treat was used for that, but this was limited in effectiveness because you started getting desorption of contaminants from the aquifer matrix, and then things quickly moved on to more in situ methods, enhanced in situ bioremediation and in situ chemical oxidation. PCBs has a lower mobility, but it is also persistent. You don't get those larger plumes by and large with PCBs, so focus on some containment, in situ stabilization and passive barriers. And now PFAS, as we've been working through the evolution of that, again, diffuse, mobile and persistent plumes. It requires kind of a more, I suppose when you look at trying to clean up an entire plume, it becomes a lot more cost prohibitive in terms of what you have to actually do to clean up an entire plume. So it's pulling it back in some respects to what you can do more closer to the source, and treating the source. And with PFAS's footprint in a groundwater sense, you do get those commingled plumes, whether they're connected with some of the original source areas. There were fire training areas that they had accelerants that were used as part of the fire training exercise to obviously create a fire. You have to have some flammable compounds in there to do that. So you get these co-contaminants in PFAS source areas, but again, through capture with large diffuse PFAS plumes, you do often get capture of co-contaminants in those plumes. That essentially means you have to consider kind of treatment trains. So you're looking at one treatment technology for one particular contaminant, but then another for the PFAS as well. So that adds to your cost and the complexity of cleaning up contamination. So you do start shifting towards that practicability, the CUSFARP process, and a risk-based cleanup that's potentially looking more at what you can do in terms of source and ongoing contribution to contamination. Next slide, if you're ready.
Yeah. No, thought I had something, but I'll move.
Yeah, this is really just building a bit more in terms of those sources, and when you've got a PFAS source on site, if you're working through practicability of cleaning up those sources, you really, from an information perspective for CUSFARP, you need to demonstrate again that CSM, conceptual site model, building a picture of the residual contamination concentrations of when you're looking at PFAS, an accurate assessment of mass in the source areas. And this goes for all contaminants, in fact, to show that you've got a good understanding of that mass, whether it's in the soil as a secondary source, in the groundwater, in primary sources. What is the mass you have still within your source and source area? And then what does cleanup look like, and what mass are you able to kind of reduce through cleanup, and overall contribution to contamination. So that is then used to frame the overall flux and movement of contaminants, any residual movements, and obviously feeds through to assessment of risk as part of that consideration as well. It's building, and it's an important part of risk assessment in the conceptual site model when you're looking at cleanup as far as you can to produce a risk-based outcome for cleanup.
So just wondering if we've got one of these combined plumes and you've got one contaminant that's deemed to be the most risk, that's the most difficult to clean up. And then you've got a whole bunch of others that are also a risk potentially in the future, but not the greatest risk. They come in second, third, whatever. But you could practically clean those up, but you can't clean up the worst one. Where do we draw the line in terms of CUSFARP there? Do we say, okay, we're going to clean up these others, but it's really not changing the whole risk ranking of a site? Or do we just move to a management point straight away?
You're looking at a risk, site-specific assessment of that risk, and what are firstly, what are the real connections with receptors between the source and the receptor? So in a simple sense, if you don't have a connection, you don't have a risk. So that's the first part. But then getting into the detail of where you do have that connection, that really helps you inform and prioritize cleanup by and large. And I think, yeah, when you're looking at, I've gone blank there. When you look at cleanup of, it's a practically a technology trade-off. I guess it depends on the contaminants as well. You know, you may have the site-specific setting when you're looking at geology, hydrogeology. All of these elements, and they're all captured in the guidance document, feed into the overall vulnerability, sensitivity of the site, and how that's translating into a future risk for any residual contamination that's left, whether that's contamination that's been able to be cleaned up or not. By and large, there are technologies to clean up most contaminants, but it is then this Venn diagram of technical, logistical, financial, and then the sustainability elements of cleanup as well. So all of those form a Venn diagram of your consideration in terms of practicability of cleanup of the different contaminant types if you have a commingled plume.
Okay. Thank you.
And that was almost a segue into the kind of last element in that overall practicability cleanup. When you've got a say a PFAS plume off site, it's quite extensive. Then trying to clean that up 100% could result in quite an extensive cleanup program. So you're going to have a lot of energy use, groundwater consumption, disturbance of land, potentially impacting on sensitive ecological receptors. So you may have a sensitive wetland and that type of thing. So when you're looking at the footprint of cleanup, certainly from a sustainability and environmental impact perspective, you do have to start thinking through the broader net environmental benefit that comes from that. Is your cleanup ultimately going to be very energy intensive? Certainly with PFAS and cleaning up or destroying PFAS, some of the methods are quite energy intensive. And again, to clean up a broad scale plume will require feasibly kind of putting in an extensive groundwater network potentially to extract contaminants already in the aquifer. So it is just considering that overall net environmental benefit that's going to be achieved through cleanup of a site as well, and that feeds into those broader considerations for practicability of cleanup. Slide, if you haven't got a question for me.
I'll give you a rest.
Yeah, and before I think of jumping onto case studies in a second, but it is just talking about the role of the environmental auditor. This guidance is a document that they have to consider when they're undertaking environmental audits, and they're obviously appointed by the EPA as experts to oversee this process and ensure that all the components that feed into a CUSFARP determination and decision are there, and the multiple lines of evidence that you've been obtaining for the site come together to justify both the remedial approach, but also justify the outcomes. And so really the environmental auditors, the EPA used to make decisions in terms of groundwater cleanup, used to be in-house effectively, but now it's auditors are able to make that determination, but they are still talking to the EPA about CUSFARP determinations, certainly to make sure that EPA is on the same page in terms of all elements of the CUSFARP determination are in place. So it is a key element of cleanup. It will more often than not have an environmental auditor engaged as part of a notice and as part of an environmental audit to review and essentially look at that CUSFARP determination process.
You find that process plays out as Are you typically on the same page, or um,
Yeah, I think it is. This is all part of the process of cleaning up a site. Is you've got your keys, obviously your client more often than not, but the auditor is a key stakeholder in the on the cleanup journey. So trying to distance them or otherwise is probably not going to leave you sitting very well. So communication, as I've found through the years, is a key one in terms of working through the cleanup process and obviously communication from investigation through looking at remedial options assessments and even going through validation, having the auditor involved through the process and communicating along the way helps for a smoother process ultimately and keeps you on the same page. So you're not turning up at the last second and going, we think we've got CUSFARP.
and how are they coping with this concept of, the fact that background and that side of things is more contaminated? Are they moving with this?
Yeah, I think, yeah, by and large, it is still an ongoing question of, you have your sources on your site. I'll kind of cover those in some of the case studies, but it is a simple story in some respects of, is your sort of site a source site? Are there kind of background sources that are contributing to that, whether that's a broader study that may indicate a contribution or specific source sites that are off-site and upgrading to your site. It is all information that's captured in the conceptual site model, which is part of the CUSFARP determination and process. So demonstrating a robust understanding of your site and the surrounding area and the contribution of that is a key component of the whole CUSFARP process and what's ultimately kind of captured and documented in the assessor's report and the environmental audit at the end of the day when you're going through an environmental audit process.
It's been a bit common feedback at some of these working group things I've been on, that like around landfill stuff, that it's been hard to get audits aligned with EPA's expectation on, say, some of those construction audits, facility based ones, but you're finding it's okay. It's not such an issue.
Yeah, you work through each site on a site-specific basis, so you are framing the influence of the site, and if a site is a source site, such as a landfill, you are kind of looking at that. But I don't. Yeah, I think it is that communication piece through the process. I'd perhaps kind of lean on that more to make sure you are aligning with the specific auditor's expectations and an EPA perspective as well.
Okay, that's good news. All right, over to your case studies.
Yeah, so this is a former industrial site. So activities on the site have resulted in solvent and PCB contamination. Kind of centrally on the cross section at the bottom of the page, you've got a commingled plume. There's some solvent and PCB in there, and then on the right hand side there's historic storage that's related to that's resulted in solvent contamination. So there were groundwater plumes, and they extended obviously beyond the sources and had been delineated through work that had been undertaken over the last at least the last 10 years. So the definition of the plumes, which is an element of the process, was well understood, and plumes were defined. In terms of risk, the associated risk, groundwater use on the site, with it being a commercial industrial property, was limited. So, in terms of an abstraction perspective and use of groundwater, say for drinking water, and broader environmental values on site, the risk was low, low and acceptable. But you did have a residual associated with the solvent contamination there. Residual vapor risk that we had to assess in that perspective. So along with the groundwater monitoring, there was vapor bores, vapor pins, and indoor air monitoring to assess the risk to ongoing users at the site. With that and the geology at the site, the plumes were relatively limited in extent. It was quite a tight clay geology at the site. So definition of the plume and the extent of the plume was limited to the site. So risk was demonstrated to be reasonably low. Some of the site redevelopments have actually, over the last, I think 20 years at least, had actually kind of removed some of that source. So some of the source had already been removed as a result of prior redevelopment of the site. That all fed into consideration of cleanup for the site. So this one didn't end up resulting in cleanup of the groundwater as such. And I suppose it's a bit of a live case in this sense, in terms of we're just working towards that kind of risk-based outcome. But at the end of the day, with the residual risk on site relating to groundwater and the residual vapor risk on the site, it's going to be an ongoing groundwater quality management plan is the likely outcome of that, to monitor those risks and any further expansion of the plume. So that's case study one in terms of where we got to in terms of looking at cleanup and practicability of cleanup with that one.
So a fair bit of residual left in the groundwater, but going to be managed with a monitoring program. Is that what you're saying?
Yeah, but through, there's a lot of monitoring to define the nature and extent of that plume, make sure we understand the mobility, future flux contribution to the groundwater. So there was a lot of information that fed into that decision. But yeah, with the monitoring program to monitor groundwater in the future and monitor those residual risks.
All right.
Next case study, another former commercial industrial activity. Few elements to this, I suppose. You've got former, you can see there in the center of the page, the primary sources in terms of underground storage tanks made whole with various hydrocarbons. They resulted in some hydrocarbon contamination. So benzene was one contaminant that was driving the risk. This is more a basalt geology and obviously a basalt aquifer. So there was impacts to groundwater, but also that secondary source impacts from those underground storage tanks. You had equipment that had been used with kind of VOC solvent-based activities. So some of the storage of that activity over time had led to solvent contamination of the soil and underlying aquifer, with it being a dense non-aqueous phase liquid. Bean apple has a propensity to sort of move downwards to groundwater and in the aquifer. So that was sitting in the aquifer as a secondary source associated with that. Also, with the history of the site, you had a potentially, and this is going back to the 50s, had a use as a former electroplater. And there was also a factory fire, which had anecdotally potentially used PFAS-based aqueous film-forming foam, or AFFF. The electroplaters also, when you look at the PFAS NEMP, can be linked to use of PFAS-based mist suppressants as part of that activity. So again, two PFAS sources on the site that we had to investigate and feed into our conceptual site model. So a number of potential sources in the first stages of investigation that we worked through investigation and framing it up in terms of the conceptual site model for the site, which this figure is kind of an illustration of where we got to in our understanding of the site setting, the geology, the hydrogeology. Another point to note is really the potential pathways. You can see a sewer there just up on more on the right-hand side of the screen. That also have the potential to kind of act as a potential conduit or pathway for contamination, both from a vapor sense, but also in terms of contaminant transport or leakage of that sewer from other sites, adjacent sites that may be using that sewer as well. So that was the initial framing of the site. And the next slide has a kind of where we got to in terms of the cleanup the site. So in building that understanding, and the proposed use of the site was for a residential development. So there was a basement incorporated into that development. That then fed through in terms of understanding of risk with basements and the residual contamination in the aquifer and in the groundwaters, potential vapor risks that was monitored and modelled in terms of the proposed basement design. The electroplater and we actually undertook sampling in the vicinity of the old electroplater, found that PFAS certainly haven't resulted in contamination of that. So that was knocked out by investigation, but also the fire as well. We had sampling as well to demonstrate the foam that was used as part of that did not contain PFAS, and so we had no potential contaminant sources as a result of those historic activities. What we did have ultimately, when we were looking at those background sources, we found there was a former tannery that had gone through an audit process, but before PFAS had really kind of come to the fore in terms of consideration there. So that had resulted in a potential as a source site for PFAS near to our site. Had resulted in a PFAS source site there. So that was really the understanding of the PFAS contribution to this site. And then we went through a series of, again, through the practicality of cleaning up the site in terms of technologies to clean up some of the residual hydrocarbon and solvent sources. So it was a component of removal of those secondary sources and talking to mass removal in those secondary sources, but also an element of amendment injection to address some of the higher concentrations that may have presented an ongoing vapor risk. So through a combination of source removal and some injection in key areas, we reached a point of cleanup to the extent practicable that was able to allow the development to go ahead with post-remediation monitoring to show that cleanup had resulted in a downward trend or a stabilization in groundwater contaminant concentrations. Lastly, to manage residual risk, there was an application that's called a check your groundwater area. It's an area, they have been called GRUZs in the past. They're areas that are put in around a site that essentially kind of cover a groundwater plume that flags that area as a potential risk if in the future with people who may look at putting a bore in to extract the groundwater. So an application of the check your groundwater area, or a SIG as they're now called, to manage residual risk associated with where we got to in the cleanup of the groundwater there.
SIG, did you say?
A SIG. SIG. People haven't settled on an acronym yet. It's relatively fresh, but yeah.
So which state are you referring to there?
In Victoria, yeah. So this is all Victorian specific.
So if someone wants to do a check your groundwater area investigation, is that just on the EPA's website or?
That's right. Ultimately, so it builds on the GRUZs as they used to be called. Similar principle where they're discoverable, so people can assess. When they're looking at their site, they can see potential areas that have been declared for that as well.
Okay, and that's a GIS sort of layer, is it?
Yeah, that's right.
Okay. Interesting.
Yeah, so just really in conclusion, some of the, especially with PFAS regulation, potentially is moving over time, and it could, in some senses, remedial technologies. I saw kind of when the initial guidance initially kind of came in and PFAS first turned up, there was obviously a response time to technologies that could be applied to that. So that's they're catching up, and as I mentioned as groundwater criteria shifts and changes, the cleanup of groundwater, so how you consider cleanup of groundwater shifts as well. overall, the principles behind ground when you're looking at CUSFARP is the Venn diagram of the technical, logistical, and financial costs and principles of environmental protection that feed into that. They're really feeding in through the CUSFARP process and audits to capture the detailed information that feeds into that process and really demonstrates how you manage to clean up to the extent practicable, taking into consideration the site constraints, but looking at background, influence of ambient concentrations to reach a risk-based endpoint for your site, and essentially ending up with a transparent cleanup process and strategy that's documented as often as part of an audit process.
Very good. So I have one question and then we better move to questions. You mentioned early on about the fact that the oceans are now potentially becoming a source for microplastics. At what point do you look at a receptor as no longer being a sort of sensitive receptor because it's already polluted?
That's a good point. I guess you've still got, there's the environment reference standard, which in Victoria again sets the quality objectives for all the different media at the end of the day. So I suppose that at the current time, and that this is, when you're looking at regulation, that's your objective for ultimately for cleanup of the site, and by extension, you kind of feed in the screening criteria to initially look at risk. So I think it's a matter of those are the objectives set by EPA to achieve cleanup, and those are the ones that we work to at the end of the day, regardless of publications that may indicate there's a broader impact. You still have those desirable impact objectives to work to under the environment quality objectives that are set.
That makes sense. There's a little bit of promotion for JBS&G. Looks like you do a lot in this area, Ross. Excellent.
Indeed.
We had quite a few early bird questions. Question number 1, how important is the monitored natural attenuation? When is ongoing monitoring warranted if NA has been demonstrated?
Well, that's probably the point. I mean, if you're reaching an endpoint and your monitoring is demonstrating that you've achieved concentrations through natural attenuation that are below your risk levels, that is the point at which you can reach a point of closure on the monitoring program. And it's a good point with those monitoring programs that are linked to a CUSFARP determination. There is a review period often set with that, whether that's 2 years or 5 years, to review monitoring over time, how those concentrations are changing, hopefully reducing because of the work you've done on the on-site sources, etc. And then circling back to look at the risk, but also to some extent looking at the evolution of technologies that could be used to address any residual contamination as well. So, but it is, again, to talk specific to that question, you are talking to the risk assessment that you undertook when you were working through the CUSFARP process, and talking to that as part of your monitoring program to see if the concentrations you have at the end of a particular monitoring period still mean you have to monitor residual risk.
So that's the importance of getting the monitoring parameters right.
Yeah.
Question number 2, what minimum distance from the LF footprint is recommended for groundwater surveillance bores to allow for attenuation? Legacy unlined. A lot of acronyms today.
Assuming that's landfill?
Maybe, yeah, minimum distance from landfill footprint, maybe. Unlined municipal solid waste.
to allow for attenuation, legacy attenuation. It's aquifer specific in some senses, because it's not just a set distance away from it. You've got to understand your aquifer. I suppose the microbiology in your aquifer, especially with landfill, is looking at attenuation of some of those, some of the elements that come out of the landfill, but also in terms of contaminant terms, hydrocarbons, solvents, they're all getting acted on by the bugs in the aquifer to an extent. So it's less about trying to demonstrate attenuation, but it's confirming your site-specific conceptual site model that will determine that distance and the risks and groundwater use around a particular site, source, landfill, or otherwise, in my mind, that would set that distance away to demonstrate it. Because you're not just looking for a zero at the end of the day for the sake of it. You're trying to, if you've done modelling of the site, you're trying to demonstrate a correlation with that modelling and correlation with the reduction in risk profile away from the site relative to sensitive receptors that are around a particular source.
Not an easy question, that one, Ross. Number 3, I'm very interested in how Victorian EPA are handling retrospectivity for PFAS with the recent NHMRC drinking water amendments.
Well, it's like when it's shifted in the past, you may, unfortunately, some sites may be in the middle of a cleanup, and that's when again, the engagement with the auditor and EPA is to discuss, okay, what criteria are we applying at this point? But if you're looking at a new site, you're essentially kind of applying the criteria that apply at the time of undertaking that investigation. That applies to decisions and audits that are undertaken. Auditors are very experienced, but I haven't seen them with crystal balls in terms of where criteria are going to go. So they can only apply the criteria and the guidance that's available to them at the time of doing an environmental audit. So in terms of retrospectivity, those audits are done at a point in time, and represent risk based on the available information at the time of doing that audit.
But Ross, would if you've had an audit done, yes, it's about a certain point in time, but the trigger for further activity and this retrospectivity side of things, would that still need, like, someone's applying for something that triggers the Planning Act? So effectively, until that happens, is that still the point? So it would need to be a redevelopment or something like that. It wouldn't be they come back to a site.
Yeah, yes. At the end of the day, but I mean, you do also have to think about the environmental duties under the Environmental Protection Act as well. So if they came in and in recent 2021. So again, it's the occupier of the site or person in management or control of the site has a duty to look at risk as well. So it's not just tied into the audit process, but the audit process, when you're undertaking an audit, you are looking at activities that are going to be part of the future use of that site. So the audit does consider, often there will be a development, so they will have a development design, and they will obviously look at people using the site and what are the practical. So it may be residents using the site, people doing construction work on the site, but very little groundwater use. And so it's realistically what the activities are on that site as part of that audit. If they change because of a change in land use, that's it, as you say, it does often go through the planning process, which triggers a change in land use and can potentially trigger the need for a new audit, which will then reassess the risks based on the proposed uses and activities on the site.
So this duty side of things, Yeah, interesting. So if someone did do an analysis a while ago for PFAS associated with an audit and still said, well, PFAS isn't a big deal because it's a while ago, that in itself, that duty there'd be a duty to reopen that.
Only there are certain contaminants that are nominated under that duty, and I think PFAS still needs to be considering. Yeah, when you've got that change in use and it potentially represents a risk, you do have to think about it as a site owner.
Okay. Number 4, how will compliance be determined?
I hopefully may have answered some of that in the slides, but at the end of the day, in a simple sense, you have your tier 1 criteria, and that's an easy. If you're below those criteria, then compliance is determined. But once you start looking at a practicability discussion, then you are going down the path of a more. I think those Venn diagrams in the end slide there probably frame it the best in terms of it's not just a simple answer of one aspect of compliance, and especially with remediation to the extent practicable, you have solvent affected sites, and it's not necessarily criteria you're looking at. It's actually the ability of that remedial method to continue to remove contaminant mass from the aquifer. So in that sense, you're looking at a kind of reduction and a plateauing of removal of contaminant removal as a compliance or an endpoint in remedial terms, which is then linked through to what is the residual risk associated with the endpoint in cleanup.
I guess another way to answer it is when EPA and the auditor agree. Is that once you're in CUSFARP, isn't that essentially?
Yeah. Sorry, that's probably the simpler way. That was my bit was the busy part before going through the audit process and the auditor agreeing and having that discussion with EPA in terms of CUSFARP and finishing the audit. That's compliance.
5, how can practitioners demonstrate compliance with the CUSFARP when dealing with emerging contaminants? I think we've probably covered most of that.
Yeah.
Number 6, are risks to modified surface water receiving bodies underestimated when applying groundwater discharge mass flux approaches?
Modified surface water bodies. You mean stormwater, or are we talking about?
I think what they're referring to is like it could be the Yarra River, and that's considered a modified ecosystem. So I think they're referring to that classification as like the Australian Water Quality Guidelines have of moderately, and
that's right. Yeah, and you do. There is allowance for that in the guidance. The criteria I showed up there was for 99% species protection, but you have modification down to 95, 80%, which reflects, as you suggest, is the significance of that particular waterway, surface water body. So there is ability to move up and down, but with PFAS, you have to account for bioaccumulation. So you naturally, if you say you have a highly modified water body, 80% applied, you could argue you actually have to jump up to the 95% criteria because you're accounting for that bioaccumulation factor with PFAS.
Do you find in most sites that people do bump it up?
It's part of the guidance, and it accounts for the behaviour of that contaminant in receptors, ecological receptors. Unfortunately, it's that propensity for bioaccumulation in all species, humans included.
So the answer to number 6 would be yes, unless you do bump it up. That's right. Yeah. Number 7, what is the definition of future use? The risks may be acceptable in the current situation, but what about in the future?
Yeah, that talks to some of the audit process we were talking through. When you're typically undertaking an audit, you are looking carefully at what is the current and often proposed future use for the site, whether that's a development, and you may do it to development plans. So yeah, you are looking as far as reasonable to look at the future use of the site and the activities and receptors that will be on that site in framing, and that's all part of framing your conceptual site model again to demonstrate the understanding of activities and potential exposures that may open up depending on the activity. That also talks to offsite, of course. With PFAS, you're looking at behaviours both on and offsite and the risks that are associated with that as well.
That must hang over you a little bit doing an audit. Like someone's making a call there of what the potential future use would be, are they not? Like, is there an exposure to an auditor if they sign off on something and it's triggered again in the future?
The audit report and even their scope of audit that they submit to the EPA kind of frames the potential uses on the site, and say they tick the low density residential box, and that has a set understanding of potential use, open space, consumption of growth and consumption of vegetables, say with low density residential. So there are set conceptual site models through the NEPM and otherwise in the auditor guidelines, allows auditors to essentially frame. So if they're talking about low density residential, this is what it means in a conceptual site model sense. Now, it does make the conceptual site model very important, because you have kind of a generic one which will help them frame up, and it helps the investigator frame up the risks and activities on the site, but it is looking very deeply at the conceptual site model and all activities on the site, and documenting those as part of the audit process is the best way to do it.
Question number 8. What is the best way industry and regulators can manage increasing data and information needs in relation to site history?
I think with data and information, there are some quite good sources of data and historical information, fortunately, through the digital age, and thinking back to what I used to have to do as part of the site history investigation, which was quite a manual process. We're probably in a better position in terms of that data and information to form a picture of the site. I'm probably talking from my perspective, because it was, you'd be off to get aerial photographs from one place, go and get some other historic records from the library, a whole range of things. And it still happens to some extent, but by and large, a lot of that site history information is now, from my perspective, I think it's actually easier to get that data and information at your fingertips.
Definitely. And we've had a couple of webinars from organisations that provide that service.
Yeah.
Number 9, has there been a review of historical QTEP decisions and risk of harm based on current state of knowledge and technology?
I can't answer. That's probably an EPA question to answer, but like I mentioned, through the groundwater monitoring programs, you kind of have a sunset on those programs more often than not to review the data, look at the suitability of that monitoring program as part of a site closure requirement, and then modification of that monitoring program that would address any shifts in risk or concentration. But in terms of a broader look at QTEP decisions, I couldn't answer that specifically.
Next question, number 10. What are the impacts of nitrate-based fertilisers and synthetic chemicals used in agriculture on groundwater compared to mining?
I haven't got specific experience in that sense. I'm afraid
It's a good question. I could probably say that in Europe, I just went to a conference there, they would say that nitrate's the biggest problem
Mhm.
in the country because of algal blooms and accumulation of nitrate to the point where they're sort of getting close to their drinking water criteria.
Yeah,
Um, and agriculture's, I mean, broad and diffuse, but ultimately accumulates in waterways.
yeah,
Mining, you have some of similar problems because of acid mine drainage and that side of things. But I'd
indeed.
say the footprint of agriculture is wider than the
Mm,
footprint of mining. It's probably two
yeah,
wrongs don't make a right, though. We need to fix them both up.
that's right.
Um, Number 11, when can you close out remediation?
I probably touched on that in an answer to a previous one. Again, you can determine site-specific cleanup criteria that say solvents, and you modelling the residual risk both in a drinking water sense, but also in a vapor migration sense to a particular for a particular development or otherwise. So there are site-specific criteria, but as I also mentioned, there's kind of remedial and mass reduction endpoints where you have a plateau in that ability to reduce mass. Saying like basalt aquifers are relatively difficult in the sense that they are fractured and you don't have a kind of clean way of extracting or injecting amendment into aquifers. So it does complicate the remedial process and the ability to achieve 100% cleanup of aquifers. So it does come back to what is your endpoint in terms of that plateau in mass reduction that you see as a potential contaminant removal as part of your treatment system that would potentially be running in terms of ongoing post-remediation to continue to clean up the aquifer.
All right, we better move to the Q&A questions. You going all right, Ross?
On the water.
Okay, I'm just going to move your head out of the way to find the Q&A. All right. Andrew Mitchell, tell us about the more recent draft ANZG levels.
It's an interesting, I suppose, modification, and I suppose it's something that grappling with at government levels. So I suppose my observation is that there's a difference in toxicity reference values that have been applied in the makeup of those criteria as it relates to the PFAS and EMP, and then what now applies to the ADWG. So that's probably something that's got to play out. But at the moment, those have become the new criteria that we refer to moving forward for the time being, until there may be a shift in terms of looking at how those get adopted in, say, a future revision of the PFAS and EMP and become enshrined in that document. But when you're assessing at a site-specific level the risk associated with PFAS, I do see kind of that shift in the toxicity reference values that have been used to form the different criteria. Those kind of get pulled through to a site-specific assessment of risk when you're looking at more detailed risk assessment. So it will change potentially how you look at risk on a site-specific basis as well. Plus, you've added in PFBS. Now, suddenly they've decided they've got enough toxicology of PFBS is now suitable to derive a criteria for that as well.
Just help me out here, Ross. So ANZG, is that Australia, New Zealand groundwater guidelines or something? What's an
That's right.
ANZG? Yeah,
Yeah.
okay. We're going to ban all acronyms from future webinars. Noting that the number in the NEMP is a draft value from 2015. So that was the other part of his question. All right, thanks, Andrew, for that one. Rod Harwood. This question, I'm sure, has been asked numerous times, but once again, how many documented epidemiological data is there to support actual harm to human health and the environment?
From PFAS we'll talk about.
I guess so.
Yeah.
Maybe it's
Yeah.
referring to all contaminants.
Yeah, there has been epidemiology done, but I've not seen certainly some of the the bigger investigation programs have looked at some of the epidemiological studies, but I've not seen the results of some of that, unfortunately.
We did have a webinar about 12 months ago on that topic and how they determine the toxicity, etc. Not sure if that covers that. That's a tricky one, wasn't it?
It was.
Then Rod's got another comment. I recall when I first joined this industry that we measured a large number of petroleum individual compounds, but then finally focused on BTEX and then BTEX N and a range of TRH groupings. So criteria shifting to groupings.
Yeah, that's product of, again, like PFAS, is kind of evolution of the science and understanding, but also policy changes as well that underpin some of that change as well.
Given all the sort of combined risks of mixed compounds, and that so many plumes seem to be mixed anyway, is it really sensible to be analysing all these separate compounds?
Well, it's almost a webinar in itself, is risk assessment of mixtures, because when you're looking at risk, they often are very linear, looking at the risk of individual compounds, and so that consideration of the combined impact of contaminants is something that's again, I feel like it's not, I'm probably talking out of school with, I'm not a risk assessor, but I feel like it's in its infancy in some respects still. When you see risk assessments, they are looking at often the specific compounds that really drive the risk. Benzene was what kind of brought up there.
I went up that old webinar. Rod Harwood persisted with a third entry. It would appear we are now following the same pathway for PFAS compounds. This is a step forward so we can focus on what we know instead of some thousands of compounds. So I guess he's arguing for a grouping approach.
Yeah, and it's worth, I mean, when you look at the PFAS sphere, it's kept, like, not all of them are toxic. So when people there's 7,000 PFAS compounds, it's only some are toxic. So there is a bit of a nuance to that overall narrative, I guess, and just make an observation in that respect.
Which ones, Ross? So there's the problem, right? There's a lot of them to check.
That's it.
There is a water RA research-based trigger point for investigation of PFAS in recycled water, but not a set limit. Okay, that makes sense. So there is a criteria for wastewater, but it's trigger point for investigation. Thank you for that, Pam. Anonymous attendee, I may have missed it, but is an auditor required to obtain CUSFARP acceptance from the EPA?
The used to be that the EPA actually determined it, but now the auditors technically are able to determine it themselves, but I think there is there's communication between the auditor and the EPA as part of that process. Whether that's written or unwritten or auditor guidance specific, I don't know, but that's been my observation, is that they communicate with the EPA as part of that determination process before formally kind of submitting the CUSFARP.
So can an assessor submit a CUSFARP application without an auditor involved?
They will. I think it's linked to an auditor. At the end of the day, you can go through the process, but often notices and audits obviously by default have an auditor often attached to it. So it is an audit-led process. And you often get degrees of the investigator kind of doing most of the work on the CUSFARP information that's required, or sometimes the auditor will be kind of collecting that information and doing a bit more of the work. So,
Right.
yeah.
So I think the answer is yes, need an auditor. Simone Sakamoto, with an estimated 7 million different PFAS compounds, is that right? What do you think of the lack of government intervention regarding source control? It does raise the question of the value in remediating relatively low PFAS concentrations in environmental media when the source remains largely uncontrolled, given its continued presence in everyday products. It's a pretty good point.
Yeah, but governments have responded by obviously phasing out. It's certainly in Australia and other countries have started really phasing out PFAS in products. Unfortunately, it just takes time when you have source sites and residual uses on sites as well. So there are still some allowed uses of PFAS-based products, but they really are kind of slowly whittling down to minimise that.
Thing on the radio this week about all these early onset cancers in people in 30s, and they were attributing it to contaminants, drawing a linkage.
Mm.
And they had a specialist on who said there just seems to be a hole between our willingness to adopt, chemicals in life for a particular use versus understanding its toxicity. So it seems there is a gap there.
Yeah.
I think we need to tighten up on it. I agree with Simonia there. Important. For case study 2, has vertical cross-contamination been considered? Therefore, the installation of that deep well created a migration pathway for chlorinated hydrocarbons into bedrock? Question mark.
Well, I'm going to use an old phrase, telescopic drilling techniques minimize that cross-contamination. So you essentially kind of drill through a plug which prevents that the upper aquifer actually going through.
Next question. We're getting near the end, Ross. Alison Reynolds. A lot of the ambient PFAS reporting that has come out concerns groundwater and surface water. Do you anticipate ambient soil investigations being released soon?
I think EPA has an ongoing program is all I can say, but in terms of publishing of additional data, I'm not sure of the time frame of that. That's all I can say. Yeah, not any specific dates that I have in mind. No.
Okay, last question. It's an anonymous attendee. What are common industrial sources of PFAS? I have come across consultants who narrow their view to airports, firefighting, and defence lands. Is there any EPA guidance on potential sources?
It's actually in the PFAS NEMP talks through potential site sources. So that's the first port of call when you're looking at activities, and it is broader than airports and defence sites, certainly landfills. I could bring it up, but there's quite a long list of activities that potentially use PFAS-based products. At the end of the day, I did read quite a scary paper that went through PFAS use in quite a lot of detail, makeup, a range of things that scared me a bit in terms of what it was in, contact lenses. And I think some of this is historic, it's not current, but it surprised me where it is used. But because it's hydrophobic and hydrophilic, fat and water repellent, it's become quite a use. I was over in the US last year talking to somebody from NASA, and they're phasing out 3M and stop producing, manufacturing PFAS essentially. And so talking to somebody in NASA there, actually, they were talking about stockpiling their PFAS products so they could continue to manufacture or build their scientific components, because it allows, like, if you think in a electronics perspective, it allows you to kind of put componentry closer together if you have a PFAS coating on it, I think is where he was going. So yeah, there are still uses that allow us as a society to go and explore space and all these things. So it is a tricky one, because yeah, the environmental impacts are obviously important, but so some people would argue so is space exploration as well.
That's an excellent answer. Well, thank you very much, Ross. That's got us to the end of the questions. I thought that was a fantastic presentation, but also great questions. So thanks very much, and thank you very much for joining us on the webinar.
Thank you. Thanks, everybody.